Today we're going to look into a GCSE required practical on paper chromatography. By the end of this video, you should be able to describe the process, the method of chromatography, explain how the method works, explain the reason why chromatography works, and you will be able to analyze the final chromatogram that you get to identify the components in a mixture. So chromatography is literally a method of separation. Now, you would, at GCSE level, you would need to know the full method of this particular practical. So I would recommend that you learn this method. This is in your exam, you would get this for a 6-marker question. You're allowed to write down the method in bullet points. So just make sure you learn the key points. The key points are you would need a filter paper because we're using a paper format. You would have to hold the filter paper to a glass rod using a paper clip. You would need to spot your paper with the ink. That means you would need to take a ruler around 1 centimeter or 2 centimeter from the bottom of the paper. You would put some marks depending on how many ink samples you've got. If you've got samples of ink in the liquid form, then you would need to take a very thin, narrow capillary tube to spot the ink. Or if you've got the ink samples in the form of felt tip pens, then you would literally take the felt tip pen and spot the ink. So you would label the ink samples A, B, and C. Then you would slowly immerse the filter paper into a beaker which contains a solvent which will be able to dissolve those ink. Now, in this case, the solvent is water because the ink is water soluble. So that is something very important. You must check whether the ink is water soluble or not. Otherwise, if you start the practical, you will have a very long wait because if the ink is not soluble in water, nothing's going to happen. So to avoid frustration, always do a check of the solubility. Once the experiment is over, you would get a result in this format. So let's say your ink H was a mixture. By looking at the colorful spots, you can see the pattern. The H contains the same spot as ink G. Therefore, it shows that H contains G. It also contains F. So you could say that the H is a mixture of G and F inks. Now, why does chromatography actually work? If you think about it, on a paper, you've literally put spots of ink. You immerse it in water, ink is there on paper, the paper does not move, so that is your stationary phase. And water starts climbing up on paper, so water is now your mobile phase. Now, as the water climbs up the paper, it comes in contact with the ink, and the water will dissolve the ink and it will wash the ink particles above along with it. So the ink components will dissolve in water and it will rise up. Now, the ink particles which are more soluble in the mobile phase or on water will rise to the very top. Those which are less soluble will stay at the bottom. So the inks which are more soluble move up, or you can think about the heavier particles will move slower, lighter particles move quicker. So you would get always a separation in that format. The number of spots will indicate the number of dyes or the components in an ink, and the height is something that you would use to measure, and you will use it to identify the components. Analogy to think about the movement of the ink. So the reason is how soluble something is. Now, if you think about these cars, if they all have the same engine, which car will win? So we're thinking about the particles in ink. All of them are soluble in water. Which ink will go to the top and which won't? So if you think about these cars, which one will win? So let's have a think about it. And then let's see on the count of 3, 2, 1, and the cars go. So you can see that the lightest car goes the fastest, the heaviest car goes the slower. The same thing applies with a chromatogram. The ink that is light, which is the most soluble, will rise up to the top. The ink that is least soluble stays at the bottom. And the number of spots, as we said, indicates the number of substances in the components in ink, and the height is used to identify the substance. There are different types of chromatography depending on the mobile phase and the stationary phase. So the separation depends on how attracted something is to the mobile as well as the stationary phase. If you're using paper chromatography, your stationary phase is paper. If you're using TLC, which is thin layer chromatography, then you will use special plates, which is the thin layer chromatographic plate. And at that point, the stationary phase is your silica gel. So your stationary phase would be powder. Column chromatography would have a column packed with a powder through which you pour your separation mixture. You could also have gas chromatography. So there are different types of chromatographies depending on what is your mobile phase and what is your stationary phase. So at the end of it, you will get something colorful like this, and that's your chromatogram. So you would get questions like this: describe how a chromatographic experiment works, and you got to link the movement of the particles. Now in this case, you could use the analogy with cars, or you can even think about people swimming in the pool. Those who are very fast swimmers will go to the top of the lane very quickly. Those who are weak swimmers will struggle, and they will stay at the beginning or at the start, near the start line. So the same thing applies here. Those ink samples that go to the top are very good swimmers, or they are very soluble in water. So common examples of chromatographic question. So these are application-based question. In this one, you've got a blackcurrant flavored drink was analyzed for artificial colors and flavors. So a scientist used paper chromatography to identify artificial colors in the drink. You've been given the chromatogram. So the key is here. So there's a lot of information in the question. So read the question, maybe read the question twice to figure out what is given and to collect all the information. So C1, C2, and C3, they are the permitted colors. Permitted means they're allowed. So they are safe colors. So describe how the chromatography was done to produce this result. It's a 6 marker. So you would have to go over the bullet points that we looked into a couple of minutes ago. So you explain the full method. That would give you 6 mark. An extension question could be, is this blackcurrant drink legal? And you have to use the diagram. So remember, you've got to answer, is it legal? That's one part of the question. And the second part is you've got to link your answer to this particular chromatogram. Now you know that C1, C2, C3 are permitted colors. Now in our drink, we have got that spot the same as that. So that is your C2. So in the drink, you've got C2 ink, which is okay. But we've got this funny spot here, which is not in any of the C1, C2, and C3. So we don't know what this is. We don't know whether it is safe or not. Therefore, we cannot say for sure that that D drink is safe to drink because we don't know what this particular spot is. And that's how you would refer to the chromatogram in order to explain why that drink is not legal. So this is the mark scheme. You can talk about that. Just make sure you write. You can pause the video and write your own answer and then check the answers. Remember, when you write down the method, you could write down the method in bullet points. write as if you're explaining the practical to an alien. So think about you're writing a method for somebody who doesn't know any chemistry, but when they read your method, they can literally go and start the experiment. So be very, very clear in the method. Some of the sample questions that you can try out, application-based questions, are here. Explain why there is a lid on the container. Imagine if the solvent is there, the solvent evaporates very quickly, so you would put the lid on. You might want the jar to become saturated, so you could put the lid on top. Explain the start line is drawn in pencil, not in ink. Have a think about that. Why would you not use ink in this particular case? This is a question that you could try it out. It's similar to the blackcurrant color. How many different food colors were used in the coloring from the cake icing? You could pause the video now and you could figure out the answer and then come back and listen to the answer. Now, hopefully you have figured out the answer. So how many food colors were used in the coloring? So this is the coloring from icing sugar. That is coming from there. So there you've got one food coloring. That one is coming from there. That is two. And then you've got 3, 4. So you've got 4 different spots. Therefore, you've got 4 different colors in the cake icing. Is the cake icing safe to eat? Now we can say that these are the safe colors. We've got the safe colors 1 and 2 here, but we don't know what these spots are, so we do not think that actually this particular cake icing is safe to eat. So I hope we've done literally a whistle-stop tour of chromatography, and I hope you have understood the basics of this, and in the next few videos I will be posting some more question practice on chromatographic methods. Thank you for listening.